Okay friends, today we are going to consider a very important part of chemistry, how to identify the structures on the basis of some formulae. We are going to need the theory of hybridization plus the VSEPR, that is valence shell electron pair repulsion theory. Based on these two theories, we are going to estimate the nature of hybridization and shape and geometry of the molecule. So we are writing two very important formulae. The first formula is index of hybridization. It is half of V plus N minus C plus A. What is V? Number of electrons in valence shell. Of the central atom. M is the number of monovalent atoms whose valency is 1. C is the charge on cation, numerical charge, don't bother about plus or minus. Obviously A will be charge on anion. Please note it is again the numerical charge. So if the charge is minus 1, here we are going to put 1. Suppose the charge on cation is 1, we are going to put 1. So it is numerical value. So anion should not be written as negative and cation should not be written as positive. If charge on the anion is minus 2, we will write here as plus 2. That is the numerical value of the charge. Please remember that. In case of neutral molecules, obviously cation and anion will have zero charge. Now in some cases there will be number of lone pairs. So number of lone pairs will be determined by the formula H minus M minus D, where H is this index of hybridization, M is the number of monovalent atoms, and D stands for divalent atoms. D stands for divalent atoms. Now let us summarize this. Suppose the index of hybridization comes 2. That means the hybridization is sp because there are 2 orbitals. In the 3, it will be sp2. 4, it will be mostly sp3. It can be in some cases, very rare cases, tsp2. If it is 5, it is tsp3 or sp3d. 6, 3 plus 1, 4 plus 2, 6. And 7, the regular shape of sp is linear. sp2 is trigonal planar. This you all learned in 11th standard. sp3 is a regular tetrahedral. dsp3, there are 5 orbitals, so it is triangular bipyramidal. D2sp3 is 6, so it is octahedral. And this is 7, so this is pentagonal and bipyramidal. I will actually show you all these structures. sp is linear like this. We are straight molecule. sp2 will be trigonal planar. One molecule will be at the center and there will be three, each making an angle 120, lying in the same plane. sp3 will be tetrahedral. With one molecule at the center of the tetrahedron, and the bond angle will be 109.5. sp3d, please see, total 5 orbitals. Out of that, 3 will be in one plane, 1 will be above and 1 will be below. So let me show you the orbitals only. Suppose you draw a triangle like this. One will be in this plane. So these 3 will be in the same plane. 1 will be in the plane above and 1 will be in the plane below. 3 in the same plane, 1 in the plane above, 1 in the plane below. If a lone pair comes, the lone pair will always go in triangle. Always goes into the triangle. Please remember. sp3d, if at all there is a lone pair, it goes into the triangle. Now we have sp3d 2. You can see the total 4. So it can be called as a square pyramidal, also known as octahedral. So in this case we will have a square. There will be 4 orbitals at the 4 corners of a square. 1, 2, 3, 4. 1 will be above, 1 will be below. And please note that the lone pair, if at all is there, will always go to top and bottom. So it is a square bipyramidal, because 1 above, 1 below, so bipyramidal, also known as octahedral. And D3 sp3 is simple. It will be pentagonal, so there will be a pentagon here. So 5 orbitals at the 5 corners of the pentagon, 1 above, 1 below. That will be D3 sp3. Now we are going to consider the geometry of certain simple molecules, and then we will go for the complicated ones. Let's consider first a simple example, say sulfur dioxide. We know atomic number of sulfur is yes, what is the atomic number of sulfur? 6. So 2, 8, 6. Number of electrons in the outermost shell is 6. So let us consider the first formula of index of hybridization. It is half number of electrons in the valence shell, number of monovalent atoms, number of electrons in the valence shell is 6. O2 is divalent, so there is no divalent atom, monovalent atom. It's a neutral molecule. Charge on cation is 0, charge on anion is also 0. 6 upon 2 is 3. 3 means it is sp2. Now let us find the number of lone pairs. on the sulfur atom. The number of lone pairs is given by H minus N minus D. Index of hybridization is 3. There are no mole-bound atoms, but there are 2 divalent atoms. It means one lone pair remains on the sulfur atom which is not involved in bonding. On this basis, we can also draw the structure of sulfur dioxide. So let us try to make an attempt of drawing the structure of sulfur dioxide. Please note that the least electronegative atom is the central atom. So this is sulfur. Now if you consider the outermost shell configuration of sulfur, just like this. The hybridization is sp2 and one lone pair remains on the sulfur. Correct? So let us consider the situation S, O and O. There are 2 unpaired electrons on sulfur. There are 2 unpaired electrons on oxygen. They will form a bond. Now please note that no unpaired electron is remaining on the sulfur molecule over here. So there has to be a lone pair. This lone pair is donated from sulfur to oxygen to make a coordinated bond. And one lone pair remains unbounded. This one remains unbounded. So there is one lone pair on the sulfur atom, and the hybridization is sp2. I think sp3 should be the same situation. The index of hybridization will be half of 6. Since it is a divalent atom, there is no monovalent atom. Same thing, it will be sp2. But please note that the number of lone pairs will be given by 3 minus there in SO3 there are 3 divalent atoms, so there will be no lone pair. So in case of SO3, even this lone pair will be donated to oxygen, and no lone pair will remain on the sulfur atom in case of SO3. Let us consider ammonia. The number of electrons in our outermost shell is 5. Number of monomer atoms is 3. Charge on cation is 0. Charge on anion is 0. If you apply the formula, the index of hybridization will be half of 4. It means it is sp3. Let us find number of lone pairs. The number of lone pairs will be 4 minus number of monomer atoms 3. One lone pair remains. Now this one lone pair will reduce the bond angle by 2.5 degree. So as a thumb rule, remember, with the hybridization of sp3 and one lone pair, the geometry becomes distorted tetrahedron, also known as pyramidal. So in case of ammonia, if you consider a tetrahedron there will be a lone pair here, and there will be 3 hydrogen atoms over here. So it will be called as distorted tetrahedron. This will reduce the bond angle by 2.5 degree, and the bond angle will become 107. So as a thumb rule, please remember, if you have a molecule of the nature AB3L, I mean one lone pair, and if it is sp3, then the geometry is pyramidal. Now let us consider ammonium ion, which is NH4+. The hybridization index will be given by half. Number of molecular atoms is 4. Charge on cation is 1. Charge on ion is 0. So again I am getting 4, which is sp3. But now let us see the number of lone pairs. It will be 4 minus 4. So there will be no lone pairs. So it will be a regular tetrahedron. Now let us consider sulfur tetrafluoride. Which is SF4. In this case, the number of electrons in the valence shell is 6, number of molecular atoms is 4, charge on cation is 0, charge on anion is also 0. So the index of hybridization will be half V plus M minus C plus A, and that is 5. Now 5 is sp3d. Let us find number of lone pairs. Number of lone pairs will be given by H. H is 5. Number of molecular atoms is also 4, so it means it carries 1 lone pair. Now as I had discussed, if you remember, you can go to the previous page and also see sp3 is trigonal bipyramidal, but the 1 lone pair will always remain on the triangle. So what we will have is this. In this case, there will be 1 fluorine atom here, 1 fluorine atom here, 1 lone pair over here. This will be F, this will be F. 1 fluorine will be above, and 1 fluorine will be below, and this will form the triangle. Now please note, while drawing the structure, lone pair is not considered. So the structure will be like this only. This particular lone pair is not considered while drawing the structure. So you can see that. See the shape. How does the shape look like? The shape looks like irregular. Tetrahedron. It's an irregular tetrahedron because the lone pair is not considered in the structure. You can also call it a structure which is like a seesaw, but in general it is an irregular tetrahedral structure. So this is SF4. Similar will be HCl4 and all that. Now let us consider an interhalogen compound, say iodine trichloride, ICl3 or IF3, anything will do. Iodine is a halogen. Number of electrons in the valence shell is 7. Number of electrons is 3. Cation ion is 0. Index of hybridization will be half of, that will be 5. Right? Now 5 will be again sp3d, supposed to be trigonal bipyramidal, but let us find the number of lone pairs. The number of lone pairs will be 2. These 2 lone pairs will go in the triangle as I had explained. So suppose one lone pair goes here, one lone pair goes here, and one chlorine molecule will be here, one chlorine will be here, one chlorine will be here. As you know, we do not consider lone pairs while considering the structure, so we will have a situation which the molecule is only this much, and you can see it is a very clear T. So it's a T shape. So it's a T shape molecule, right? Okay. Now let us consider another molecule. Say XeF2, xenon difluoride. It's a halogen and it's a inert gas. Number of electrons is 2. The index of hybridization will be given by half of 5. Again it will be sp3d. But now look at the number of lone pairs. The number of lone pairs is 5 minus number of monoatoms is 2. It will be 3 lone pairs. All these 3 lone pairs will go in a triangle. So one molecule of F will be above, one molecule of F will be below, and obviously center is xenon. So the molecule will be obviously linear. With a bond angle of obvious 180 degrees. Now let us consider XeF4. Valence shell in the inert gas is 8. Atoms are 4. Index of hybridization will be half of 6. 6 is sp3d2. Just find the number of lone pairs. Number of lone pairs will be 2. Now sp3d2 is octahedral, that is square pyramidal, and in square bipyramidal I told you the lone pair goes above and below the square. So if you have a situation like this, one lone pair will go above, one lone pair will go below. This will be Xe. So F will be here, here, here and here. The shape will be simply square. It will be simply a square, and since it is in one plane only, we can call it square planar. C XeOF2. Number of valence electrons 8. Number of monovalent atoms is 2. O is divalent, so not to be considered. What is the index of hybridization? Again it will be 5. 5 is sp3d. It is find number of lone pairs. Index of hybridization minus number of monovalent atoms minus number of divalent atoms. So there will be 2 lone pairs. Again, these 2 lone pairs in case of a trigonal pyramidal will go inside a triangle. So one molecule will be here, one will be above, one will be below. So again you can say it will be a T shape. Let us consider IF7. V is 8. Sorry. Wait 7. Wait a minute. If I already done. Just to IF7. Wait 7. Number of atoms is also 7. sp3d3, which is a simple pentagonal bipyramidal, nothing to do. Because number of lone pairs will be 0, H is 7, M is also 7, 7 minus 7 will be 0. So it will be a pentagonal bipyramidal. So in this way we can have this valence shell electron pair repulsion theory, which will help us in identifying the geometry and shape of the molecule and also the index of hybridization. We can do a few more. Let us consider XeF6. Number of lone pairs will be 1, so it will be not pentagonal bipyramidal, but because one lone pair will not be considered in considering the geometry, there will be only 6 attachments, so we can call this as distorted octaedral. Because even though it is pentagonal bipyramidal, that makes it 7. One lone pair will not be considered as a geometry part of geometry. So only 6 attachments. So it will be a distorted octaedral. Let us consider one last thing. So there is one lone pair and octaedral. So in the square there will be 1, 2, 3, 4. One lone pair will go here and one molecule will be here. So it will be a square, not bipyramidal, because lone pair is not considered in geometry. So it will be called square pyramidal, not bipyramidal. Please note. It will be called as square pyramid. F, 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 O, and X. I think that should be enough. These many examples are sufficient.